give in conclusion is influenza vaccines offer protection against cardiovascular events for at least 1 year. So now the incidence of influenza is coming. So if you haven't get influenza vaccines, you can vaccinate it properly. Thank you.
We conducted a study about the vaccine effectiveness of the vaccination against COVID-19 related hospitalization in elderly adults aged 80 years old and over during the period of the Omicron circulation in Beijing. So we conclude the Beijing residents aged over 18 years, and we get their messages, information about their hospitalization from the Beijing hospital utilization information system, and we matched their vaccination data from the Beijing immunization information management systems. And we used the Poisson regression to calculate the incidence risk ratio and to get the vaccination effectiveness. And we found the vaccination provided protective effects against COVID-19 related hospitalization and severe critical cases, and in different duration. So the conclusion about our study is the booster vaccination significantly reduced the risk of the COVID-19 related hospitalization and critical illness or in hospital death in the elderly patients during an Omicron dominant period. That's all. Thank you.
Thus, I use InFold, that's a type of modeling method, AlphaFold, and homology modeling, and also a chimera model where I combine both the prime homology model, the hinge loop. Sorry if it's a bit more protein specific now. And then the rest came from AlphaFold, because when you go to AlphaFold database, it gives you how accurate each segment of the protein is. But it wasn't on the hinge, which is the part where like the aromatic rings from ATP bind. So after that, and then the protein modeling involves a lot of things, such as I'm finding an inhibitor for the ATP cavity, right, for my kinase. Now, when you're looking at proteins, you're like, okay, how does the P loop look? So the cavity is like at the top, there's the P loop, right? And then on the side, there's the hinge loop. And that's where like the rings of ATP make contact with two hydrogen bonds. And then in the P, there's the P loop, they make some contacts as well. And then you have the lysine from beta 3 that's found more towards the back. And then you also have the gatekeeper after beta 5. And you have to make sure how are these residues oriented inside the cavity, and then that kind of helps you choose the best model where you can dock your predicted possible good compounds that you find. Now, to find these compounds, my lab, we created a machine learning model, and the whole premises of it, to make it like simple, is that, okay, we know that kinases in general have relative conservation in the ATP pocket, right? And thus, we can find other kinases that are similar to our kinase in mind, and then see what compounds are known actives for it and what compounds are not known actives for it. And then those that are active, we can use to dock into our predictive model structure. So I guess updates, this, for some reason, this protein has been very interested, at least in the pharmacology field, because there has been 3 papers also apart from my lab trying to find an inhibitor for it. But the first paper didn't do any kinase specificity profiling in cells after they found the drugs and tested them in cells. So then you're just saying, oh, we think that it binds, but is it also targeting other kinases? The second paper targeted the N-terminal region of this kinase, and I'm guessing because this kinase serves as a scaffold where BOP1 binds, so that's interesting. But it was just in silico work, nothing related to cells. And the third paper that also got published on this protein said we want to find inhibitors for BOP1B, but we're going to use the nearest homologue, which is like 25% sequence similarity, and we're going to use that crystal structure to dock in it. And it's like, well, then you're finding compounds for BOP1, not BOP1B, and somehow that got published. So yeah, that's the essence of my work.
We construct a database since 1996 with systematic data analysis, and because of this, we identified so many cases of infection, and infection related to neurological problems such as central nervous system or peripheral nervous system. I'd like to say that don't be afraid. We all know little on emerging and re-emerging diseases. Thank you so much.